Hello friends, welcome to Physics with Ben. In today's video I want to teach us what we need to do in this year's Waec Physics 3 practicals examinations, especially alternative A. Disclaimer, this is not your real Waec question. My channel does not promote examination malpractice, but if you can follow my instructions and do as I say, you are going to come out with clean results in your external examinations. I want you to understand that experiments in physics is not a child's play. This is where the bulk of the marks that will give you that A1 you are looking for in physics lies. You must not joke with your experiment. That is why every year I always prepare a special video so that you guys can watch and get your straight A's. It will interest you to know that if you don't do your experiment very well, then forget about getting a distinction or even a credit in physics. So please pay attention and watch this video to the very end and try to share it to those that need it. So this is what I want to predict. We have a setup here. We have a setup here for experiment in mechanics. And this experiment is under Archimedes principle. I hope you have heard of the principle of floatation, the physics behind floating of objects in space, floating of objects in air or on the surface of water. You may love to click in the description box below to see a detailed video I did on the principle of floatation. Before you delve into any experiment in physics, it is expedient that you master the theory behind the experiment. And so that video is part of the theory behind the experiment. And then what I'm going to do here today, if you will add it up, you are going to come up very clean. So the video I'm doing here right now is just for the physics question 1, which is mechanics. And this question, we are supposing it to come from Archimedes principle. This is not your this year Waec exams, but we are hoping that if you follow through these instructions, you will come out clean. So the apparatus needed, we need a beaker. You see W, this one we're going to fill it with water, and we need another beaker. We're going to fill this one with liquid. And the liquid we are going to use here is the normal kerosene that you know. And here is a spiral spring or a spring balance to measure the weight of the object. And these are the slotted masses. These are retort stands. And to fast forward the process, I have done my due diligence, I have done my studies, and this is how your table of values will look like. This is the graph and the equations that support the experiments. The relative density of a liquid, we're going to look at this while we do the experiment. And the year we are trying to look at is this particular year. If you have your book, you can replicate what I'm doing here at home. June 2012, and this is the experiment we are looking at. And without wasting much time, let us go straight to the business of the day. So I would like to set up this, watch what I do, so that you can do exactly as I do. So we are going to set up the experiment. Before you do that, this is what I'm doing. We will not necessarily use this, although in the first question you have 2 retort stands, but we don't necessarily need to use the 2 retort stands. One of them is very, very okay. So we are going to set up the experiment. Before we do that, we are going to adjust and see how high we can take this or how low we can take it. So we are going to slot this mass and lower it in this beaker and measure where it will stop. So it means that we have to take this guy up a little bit. Yes, that's it. So what I'm doing now is called the experimental setup. I am done introducing to us the apparatus needed for this experiment, and right now we are setting up the experiments. Good. So now that we are done setting the setup for the experiments, these are slotted masses. This with the hang or the hanger is 50 grams. Each of them are 50 grams. You can see that. So 50 grams each. So the contents labeled W, we are going to fill it with water. Yeah, that should be enough. So we put it there. This experiment is trying to investigate the relative density of water, of liquid to that of water. And so right here is the content, and this content is nothing. This liquid is nothing but kerosene. So I'm gonna pour the kerosene here. I did this experiment with my students some time ago, and so this is kerosene or paraffin. So they want to investigate the relative density of kerosene to that of water. So the liquid L is kerosene, and the beaker with the L label is kerosene, and the beaker with this is water. So we are done with the two of this. Let's put them aside and begin the experiment. So without wasting much time, let us go straight to the business of the day. Good. This is a question that we are looking at, and I would like you guys to screenshot this. I don't want to read through so that I don't waste time here. So this is the question we are looking at. You can screenshot from here to here. But I want to just read one of the line. So study the diagrams above and use them as guides in carrying out the following instructions using the spring balance provided. Determine the weight of objects of mass m equals to 50 grams in air. Record this weight as W1. Determine the weight of the object when it is completely immersed in water contained in a beaker as shown in the diagram above. Record the weight as W2. Determine the weight of the object when it is completely immersed in liquid labeled L. Record the weight as W3. Evaluate U is equals to W1 minus W2, and also V is equals to W1 minus W3. Repeat the procedure. So this is what we are going to do. So you can screenshot. Good. This is what the examiners asked us to do, that we should weigh this in air and see what we have. So this is weight in air. Remember that in equilibrium of objects in fluid, that is liquid or water, the weight of the object in air is always heavier than that of the weight in fluid. This is called the principle of flotation. I ask us to click in the description of the video that we are watching, and you will see a video where I explain the principle of flotation vividly. So let's see what this weight is. It is exactly 50 gram. And 50 gram to kilogram, since we are dealing with weight here, we are going to work with standard units. So we're going to convert what you see here to kilogram. Are we good? Let's look at it very closely. The weight is measured in the standard SI unit of Newton. So we're going to record everything in the standard unit. So the grams will be converted to kilogram, and the weight here simply means W is equal to mass times gravity. W is equal to mass times gravity. And so the mass we have here, when you convert 50 grams to kilogram, you divide 50 by 1000. And so you're going to have 0.05 and then times 10. The value of acceleration due to gravity in this particular physics lab is approximately 10 meters per second squared. So 0.05 times 10 gives us 0.5. And so the weight in air here is 0.50. You see, I did not record 0.5. I did not record 0.5 the way I have it in calculator here. I record 0.50. Let us find the weight of this object in water. So I'm going to place this stuff here and lower it gently in this water. Good. If you look at it very well, this is less than 0.5. What we have here is approximately, mind you, there's a way you stand. This is how to stand and view this way. To avoid error due to parallax, this is how you're supposed to stand. So the weight is this is 1, 2, 3, 4. So on the right hand side, we have something like 40 something grams. On the left hand side, you can record the values the way they are. So what we have here on the left hand side is 0.45. So you record 0.45 Newton. I was supposed to record this 0.45 in this column, so I did a mistake. I'll still cancel that. So this is 0.45 recorded in this particular column here. So this is wrong. I will just strike this out and correct it later. We are going to take this away and bring this content. This is kerosene now. We are going to clean this. You need to have a material where you don't mix them up. We want to clean the water content away from here. So we are going to lower this here. So let's look at what we have here right now. We have something like 0.4. 0.40. Good. So we are asked to evaluate U. U is equal to V W1 minus W2. That is weight in air minus weight in liquid. And this result also means the upthrust. The upthrust of the objects in water. So we record W1. Our W1 is 0.5 and our W2 is 0.45. So 0.5 minus 0.4 minus 0.45. 0.5 minus 0.45, we have 0.05. And so we record 0.05 here. Our V is a V1 minus V3. So we record 0.5 minus 0.4. Our V3 is 0.1. We record it as 0.10. So you will repeat this process. You will repeat this process for 5 times when the mass is 100, 150, 200, and 250. You repeat this process. This is as simple as ABCD. This is what this experiment is all about. So we are going to add the masses and run it for the second time. This is 100 grams. 100 grams. So we find the weight in air. Good. The weight in air, as you can see, is 1 Newton. We are going to record 1 Newton here. We record 1.00 Newton. We record 1.00 Newton. Next up, we are going to find the weight in W2, which is water. So we're going to bring this guy here. Definitely, the weight in water will decrease. So we hang it here gently. And so what I have here is obviously less than 1 Newton. What I have here is 0.9 Newton. So this is 0.9 Newton. That is what you have there. 0.9 Newton. So we record 0.90 Newton. We will remove it. We will remove this and wash and clean this water so that it does not drop in the kerosene. And then we take it away. You see, there was no need for 2 liter stand here. We replace the kerosene and we lower it down gently. And then we find a new reading. This time we find that it is on 0.95 Newton. So we record 0.95 Newton. And so we evaluate U is equal to weight in air minus weight in liquid. That is the upthrust of the object in water. U means the upthrust of the object in water, and V means the upthrust of the object in the liquid, such that the relative density is given as so that the relative density of the liquid to that of water is given as upthrust of the object in liquid divided by the upthrust of the object in water with no SI units. Relative density is a dimensionless quantity. So we say that we have 1 minus 1 minus W2, that is 0.9. 1 minus 0.9, we have 0.1. So we record 0.10. And so the next one is we have 1 W1 minus W3. So we say again that 1 minus 0.95, that will give us 1 minus 0.95, we have 0.05. And so this is what you have to do for all of the values. Hello friends, welcome to Physics with Ben. In today's video, I just want to explain the principle of flotation using this little setup here. The principle of flotation states that for a body to be able to float in fluid, e.g. water, the upthrust exerted on the object must be equal to the weight of the object. Upthrust will act in the upward direction, while the weight will act downward. So I'm going to use this little setup here to explain. So we are done with the experiment, and if you can observe the U and the V value, you observe an increase trend. You can observe an increase trend. We have 0.05, approximately 1. Approximately to 1 decimal place, we have 0.1. These two to 1 decimal place, we have 0.1. We have 0.1, we have also 0.1 here. So in summary, U is increasing down and V is increasing down. So the trend for this experiment is increase. If you have been following my videos, I've always explained the meaning of trends in experiments. Don't forget, these are your composite parameters. This is how your table of values is supposed to be. Your table of values carries the highest mark. So now that we have discovered the trend of the experiment, whenever the trend is increase, you are going to have a graph of this nature. This graph, or this graph, or this graph. So the graph that we are likely to have here is this particular graph here, the graph passing through the origin. And it is because of the equation that controls this experiment. The equation that controls this experiment is simply what you see captured here. The graph and the equation. I worked it out before I started running the experiment. So this is the equation. UL is equals to MU. MUL equals to MUW. That is upthrust of the object in liquid is equals to the mass and the slope of the graph times upthrust of the object in water. This particular equation is looking like y is equals to mx, a straight line equation with no intercept, where the graph is passing through the origin. This is the origin of the graph. So finally, based on the parameters given from the experiments or experimental equation, question, this is this particular equation here, equation number 3, is the equation controlling the experiment. And if you walk it down, we have it here as relative density of the liquid. So what we're trying to say here is that when you plot this graph, the result of this graph is the relative density of the liquid, which is kerosene, to that of water with no SI unit. So help me plot the graph of U against, the graph of V against U. That is V on the y-axis and U on the x-axis. And help me find the slope of the graph and drop your answer in the comment box. And use this particular information here to plot your graph and find your slope. The last thing the examiners ask us to do, they ask us to state Archimedes principle. Archimedes principle is in your book. You can go ahead with it. And then they ask us to also determine, state 2 precautions. Go online and Google and find out the precautions that are peculiar for this, but I'll just drop one for you. You remember we were taking reading here. And so one of your precautions is that I avoided error due to parallax while taking reading on the spring balance. So this is all you need to do concerning this particular experiment. And then the last thing is they gave you some questions here to solve, which is the BII part of it. You can see that question there. You can go ahead and solve it. Now, disclaimer once again, this is not your Waec exam. This is just a sample of what you may see this year. Go back to your textbook and read all your books. Study Archimedes' principle, the theory of flotation, the principle of flotation, the calculations, and everything about Upthrust. Study it and solve all the questions, and then you'll be set for these particular exams. Our next video will be a video on optics. With this, we have come to the end of this particular experiment. I wish you guys success in your physics exams this year. Don't involve yourself in examination malpractice. Read your books and play your part, and then also pray to God, and then your success becomes inevitable. Thank you, and God bless you. Bye-bye.